Imagine colossal clouds floating through the vastness of space, so immense they could swallow entire solar systems. These are the birthplaces of stars, where new celestial bodies emerge, and also their final resting places after they've burned through their cosmic lifespans. Welcome to the awe-inspiring world of nebulas, the cosmic factories of the universe, where the cycle of stellar life begins and ends. These clouds, composed of gas and dust, are not only magnificent to look at, but also essential to the formation and evolution of everything we see in the night sky. They are the silent architects of the cosmos, crafting stars, planets, and the very elements that make up life itself. And what if I told you that when we observe nebulas, we're gazing into both the past and the future of our very own sun? These massive structures are so enormous that some can be seen with the naked eye, even from thousands of light years away. Their beauty is only matched by their importance in the cosmic order. Today, we're going to unravel the mysteries of these celestial wonders, discovering how they shape the universe and why they're essential for life as we know it. From star formation to the remnants of supernova explosions, nebulas hold the key to understanding how the universe recycles itself, creating new worlds from the ashes of old ones. If this cosmic journey has sparked your imagination, be sure to give this video a thumbs up and subscribe to Exploring the Universe for more breathtaking insights into the wonders of space. Let's continue this adventure together, uncovering the secrets of the universe, one discovery at a time. Nebulas, often described as the breathtaking wonders of space, are vast, diffuse clouds made up of gas, primarily hydrogen, and dust particles that float in the vast emptiness between stars. These clouds aren't just passive structures, they're the very cradles of stars, where new suns are born, and the final resting places of stars that have completed their life cycles. In scientific terms, a nebula is defined as an interstellar cloud of ionized gases, plasma, and cosmic dust. These elements swirl together, sometimes forming dense regions under the pull of gravity, giving rise to new stars and planetary systems. The origin of the word nebula is rooted in Latin, meaning cloudy or misty. In the early days of astronomy, before powerful telescopes were developed, early observers would look up into the night sky and see faint cloud-like structures that appeared hazy and undefined. Without the technology to see these distant objects in detail, astronomers initially grouped galaxies, star clusters, and true nebulas under this same term. However, as our understanding of the cosmos deepened, we began to differentiate between these objects. The term nebula now specifically refers to these grand interstellar gas clouds, while galaxies, once mistaken for nebulas, are vast systems containing billions of stars. The scale of nebulas is something that defies comprehension. Some nebulas span hundreds of light years, with 1 light year equaling about 9.5 trillion kilometers, 5.88 trillion miles. For example, the Eagle Nebula, home to the iconic Pillars of Creation, stretches over 70 light years across. The Orion Nebula, one of the brightest and most famous nebulas, is located about 1,344 light years from Earth and spans roughly 24 light years. While these numbers are mind-boggling, the true wonder lies in the fact that even though these clouds are massive, they are incredibly diffuse. In some cases, the gas and dust are so spread out that they are more tenuous than the best vacuums we can create on Earth. Imagine something so vast and yet so thin that if you were to pass through it, you might not even notice it. Nebulas are not static objects. They evolve and change over time. Some are remnants of ancient supernova explosions, where the outer layers of a dying star are ejected into space. Others are regions of active star formation, where gravity pulls gas and dust together, creating new stars in a process that can take millions of years. These clouds, despite their appearance, are dynamic and constantly in motion, shaped by stellar winds, radiation, and gravitational forces. They are not only cosmic nurseries, but also key players in the recycling of matter in the universe, redistributing elements that will one day form new stars, planets, and potentially life. Their beauty is undeniable, but their significance is even greater. Nebulas offer a glimpse into the processes that govern the universe, from the formation of stars to the eventual recycling of stellar material into new celestial bodies. They are among the most beautiful and scientifically intriguing objects in the cosmos, serving as both the starting point and the end of the stellar life cycle. The composition of nebulas is as fascinating as their appearance. At first glance, they might seem like ethereal glowing clouds floating in the emptiness of space, but they are made up of a diverse range of elements and compounds that play a crucial role in the universe. The two most abundant elements in any nebula are hydrogen and helium, which are also the most abundant elements in the universe. Hydrogen, the simplest and lightest element, makes up the majority of the nebula's mass, while helium, produced through nuclear fusion in stars, forms the second largest component. These gases are mostly ionized, meaning they are electrically charged, which causes them to glow when they interact with radiation from nearby stars. However, nebulas are much more than just gas. Scattered throughout these vast clouds are microscopic particles known as cosmic dust. This dust is made up of tiny grains of carbon, silicon, and various metals such as iron, nickel, and magnesium. Though individually minuscule, collectively, these particles play an enormous role in the nebula's dynamics. Cosmic dust absorbs and scatters light, which is why some nebulas appear dark and opaque, while others glow brightly. These dust grains can also clump together, becoming the building blocks for new planets, moons, and other celestial bodies. In regions where the dust is more densely packed, it can even form solid cores that eventually develop into stars or planets, illustrating how nebulas are not just pretty clouds, but active participants in the ongoing creation of the universe. One of the most intriguing aspects of nebulas is their ability to harbor complex molecules, including organic compounds that are the precursors of life. In the coldest and densest regions of nebulas, molecules can form that are far more complicated than simple hydrogen and helium atoms. These molecules include water, H2O, carbon monoxide, CO, and ammonia, NH3. But what's particularly fascinating is that nebulas also contain more complex organic molecules, like polycyclic aromatic hydrocarbons, PAHs, which are carbon-based compounds. PAHs are thought to be some of the most basic building blocks of life, and their presence in nebulas suggests that the raw materials for life as we know it may be widespread throughout the universe. In these dense molecular regions, called molecular clouds, conditions are just right for the formation of these complex compounds. Shielded from the harsh radiation of nearby stars, these areas remain cold and dense, allowing molecules to stick together and form. This is crucial because in the chaotic environment of space, radiation often breaks molecular bonds. However, in these protected regions, chemistry can occur, leading to the formation of the molecules that are necessary for the creation of new stars, planets, and possibly even the seeds of life. These molecular clouds are often the birthplace of new solar systems, and the presence of organic molecules hints at the possibility that life, or at least its building blocks, might be more common in the universe than we previously thought. In summary, the composition of nebulas is a complex and dynamic mix of simple gases, cosmic dust, and complex molecules, all of which play a critical role in the life cycle of stars and planets. These components are not just passive elements floating in space. They are actively involved in the processes of star formation and planetary creation. From the basic hydrogen and helium that fuel stars to the complex organic molecules that hint at the origins of life. Nebulas are the cosmic factories that produce the raw materials of the universe. They are not just beautiful to look at, but are fundamental to the very existence of stars, planets, and perhaps life itself. When it comes to nebulas, they aren't just one type of cosmic cloud. In fact, they come in a variety of forms, each with its own unique properties, behaviors, and roles in the universe. Nebulas can be categorized into several types based on how they interact with light, nearby stars, and the processes happening within them. These different kinds of nebulas not only add to the beauty of the cosmos, but also help us understand the life cycle of stars and the evolution of the universe itself. The first type of nebula is the emission nebula, which glows with its own light. These nebulas are filled with ionized gases, primarily hydrogen, which emit light when they are energized by the intense radiation from nearby young, hot stars. The most famous example of an emission nebula is the Orion Nebula, located about 1,344 light-years away from Earth. This nebula is a stellar nursery, a place where new stars are actively being formed. The bright glow of emission nebulas typically comes from hydrogen atoms that have been stripped of their electrons, a process known as ionization. As the electrons recombine with the hydrogen nuclei, they release energy in the form of light, causing the nebula to shine brightly. These glowing regions are often colorful, appearing in shades of red, pink, and orange due to the specific wavelengths of light emitted by hydrogen atoms. Next, we have reflection nebulas, which don't produce their own light but instead reflect the light of nearby stars. Unlike emission nebulas, which are ionized by hot stars, reflection nebulas are simply clouds of dust that scatter the light of nearby stars. The dust particles in these nebulas are often very fine and made of materials like carbon or silicates, which reflect blue light more efficiently than other colors, giving reflection nebulas their characteristic blue hue. A well-known example is the Pleiades, a star cluster surrounded by reflection nebulas. These nebulas shine not because they are heated to the point of glowing, but because they are illuminated by the light of nearby stars, much like how the Earth's atmosphere scatters sunlight to make the sky appear blue. On the other end of the spectrum, we have dark nebulas, Schaurer, which are some of the most mysterious and ominous objects in space. These nebulas don't emit or reflect light. Instead, they block it. Dark nebulas are dense clouds of gas and dust that are so thick they obscure the light from stars and other celestial objects behind them. The best example of this type is the Coal-Sack Nebula, located in the southern hemisphere sky. These nebulas are often hard to detect because they don't shine and are only visible when silhouetted against a brighter background, such as the dense star fields of the Milky Way. Despite their darkness, they play a crucial role in star formation, as their dense regions often collapse under their own gravity to form new stars. Another fascinating type of nebula is the planetary nebula, which is a misnomer because it has nothing to do with planets. These nebulas are the remnants of dying stars, specifically stars that were once similar in size to our sun. When a star like the sun reaches the end of its life, it expels its outer layers into space, creating a shell of glowing gas. The star's core remains as a hot, dense white dwarf, which continues to emit ultraviolet radiation, causing the ejected gases to glow. One of the most famous planetary nebulas is the Ring Nebula, located in the constellation Lyra. Planetary nebulas are often beautifully symmetrical and can take on shapes that range from rings to hourglass-like structures, depending on how the dying star ejected its material. Each of these types of nebulas, emission, reflection, dark, and planetary, plays a distinct role in the cosmic cycle of star birth and death. Emission nebulas are the birthplaces of stars, while planetary nebulas mark the final stages of a star's life. Reflection and dark nebulas, on the other hand, are often found in regions where stars are either forming or awaiting their eventual creation. Together, these different types of nebulas form the intricate, ever-changing tapestry of the universe, helping us to better understand the life cycle of stars and the complex processes that shape the cosmos. Nebulas are more than just beautiful cosmic clouds. They are the cradles of star formation, often referred to as stellar nurseries. The process of star formation begins deep within these dense clouds of gas and dust, where gravity plays a pivotal role. Over time, the gravitational pull causes certain regions of the nebula to collapse in on themselves, gradually pulling more gas and dust inward. As these regions become more compact, they heat up, and under the intense pressure, the material forms a protostar, essentially the seed of a future star. This process can take millions of years, but once the core of the collapsing cloud reaches a critical temperature, nuclear fusion ignites, marking the birth of a new star. A key element in the star formation process is the presence of Bok globules. These are small, dark, and dense regions found within larger nebulas. Although they are tiny in comparison to the overall nebula, Bok globules are crucial because they are the sites where stars are most likely to form. These globules are often opaque, blocking light, and can range in size from a fraction of a light year to several light years across. Within these compact clouds, gas and dust accumulate until the pressure and temperature are high enough to trigger star formation. The stars that are born in these Bok globules eventually blow away the surrounding material with their intense radiation, revealing themselves in the process. As stars form within a nebula, they often do so in groups called stellar clusters. These clusters are essentially families of stars that share the same origin, having been born from the same region of a nebula. Since they so as they form together, these stars are made of the same material and are roughly the same age. There are two primary types of stellar clusters: open clusters and globular clusters. Open clusters, such as the famous Pleiades, are loosely bound collections of stars that can eventually drift apart. In contrast, globular clusters are tightly packed, spherical groups of stars that remain gravitationally bound for billions of years. Regardless of their type, stellar clusters provide key insights into the life cycle of stars, as astronomers can study their formation, evolution, and eventual death as a collective group. The life of a nebula doesn't end once stars are formed. These young stars, especially the more massive ones, have intense stellar winds that push away the remaining gas and dust, shaping the nebula and often causing it to glow brightly in the process. This is why some of the most spectacular images of nebulas of creation show towering columns of gas being eroded by the radiation of newly born stars. Over time, the remaining material may either form more stars or be dispersed into space of new nebulas and continuing the cycle of stellar birth and death. If these cosmic factories are sparking your imagination like an emission nebula, then why stop here? There's so much more to discover in the universe. Be sure to like this video and subscribe to our channel for more deep dives into the wonders of space. Join us as we continue to explore the mysteries of the cosmos and uncover the secrets of the stars. Nebulas are not static, unchanging objects. They are dynamic entities that evolve over time as part of the larger cosmic cycle of birth, life, death, and rebirth. Their life cycle begins with their formation, often as a result of material being ejected from stars. This material can come from various sources, such as the stellar winds of massive stars or the violent death of stars in the form of supernovae. When a star reaches the end of its life, it can expel vast amounts of gas and dust into space, forming what we call a nebula. For example, planetary nebulas are formed from the outer layers of a dying star, while supernova remnants, such as the famous Crab Nebula, are created when a massive star explodes in a supernova. These newly formed nebulas are composed of the basic building blocks of the universe, including hydrogen, helium, and heavier elements produced during the star's life. As a nebula forms, it begins a process of evolution that can span millions to billions of years. Initially, the gas and dust are loosely distributed, but gravity slowly pulls this material together. Over time, the denser regions within the nebula may start to collapse under their own gravity, giving rise to new stars. This process is what makes nebulas stellar nurseries, as the gravity-induced collapse of gas and dust leads to the formation of protostars. During this phase, the nebula is influenced by the intense radiation and stellar winds from the young stars that form within it. These forces can sculpt the nebula, creating intricate shapes and structures such as pillars, filaments, and bubbles. As the stars mature, they continue to affect the surrounding gas and dust, causing the nebula to glow in various colors, depending on the types of elements present. Over time, nebulas can be destroyed and reborn, illustrating the cyclical nature of matter in the universe. The destruction of a nebula often comes from within, as the young stars it helps to create can eventually blow away the remaining gas and dust with their powerful stellar winds and radiation. This process can be seen in emission nebulas, where intense ultraviolet radiation ionizes the surrounding gas, causing it to glow while simultaneously dispersing it into space. In some cases, the nebula can be entirely consumed by the star formation process, leaving behind only the newly born stars. However, the end of one nebula often marks the beginning of another. As stars die, they return their material back into the interstellar medium. This continuous cycle of gas and dust being expelled, reformed into stars, and then dispersed again ensures that the universe is constantly recycling its material. For example, when a massive star explodes as a supernova, the shock wave from the explosion compresses nearby gas clouds, which can trigger the formation of new stars and nebulas. In this way, the death of one star can directly lead to the creation of new ones. The gas and dust from the supernova can form new nebulas, which then go through the same process of star formation, evolution, and eventual destruction. This cycle is crucial to the universe's ability to maintain itself over billions of years, continually recycling elements and matter to form new stars, planets, and even the building blocks of life. Nebulas play a key role in this cosmic recycling process. They are not only the birthplaces of stars, but also serve as repositories of material that will one day form new stars and planets. The elements within a nebula, hydrogen, helium, carbon, oxygen, and more, are redistributed across the universe, ensuring that no material goes to waste. In fact, the very atoms that make up our own planet and bodies were once part of nebulas billions of years ago. This cosmic cycle, where matter is created, destroyed, and reformed, is one of the most fundamental processes in the universe, demonstrating how interconnected all things are, from the smallest particles to the largest galaxies. In summary, the life cycle of nebulas is a testament to the ever-changing, dynamic nature of the cosmos. They are born from the ashes of dying stars, evolve over millions of years as new stars are formed, and eventually disperse their material back into space, continuing the cycle of stellar birth and death. Nebulas are not just fleeting objects in the sky, but integral components of the universe's ongoing process of creation and destruction, showing us that in the cosmos, death is never the end. It's merely the beginning of something new. When we talk about nebulas, a few stand out as some of the most famous and well-studied in the universe. These nebulas not only offer stunning visual beauty, but also provide key insights into the processes of star formation, stellar death, and cosmic evolution. Let's explore three of the most renowned nebulas: the Orion Nebula, the Crab Nebula, and the Eagle Nebula, each of which has a unique story to tell about the life cycle of stars and the grandeur of the cosmos. First, we have the Aish Moarforenkinen Orion Nebula, Ihasserem Yos Oidashoriraim Reichtrais, which is arguably the most famous nebula in the night sky and the closest stellar nursery to Earth, located about 344 light-years away. It's part of the Orion Molecular Cloud Complex, a large region of space that contains several other nebulas and star-forming regions. The Orion Nebula, also known as M42, is visible to the naked eye as a faint, fuzzy patch in the sword of the constellation Orion, making it one of the few nebulas easily seen without the aid of a telescope. However, when observed through telescopes, this nebula reveals itself to be a stunning cloud of gas and dust, where thousands of new stars are being born. The nebula is illuminated by the intense radiation from a group of young, massive stars known as the trapezium. These stars heat and ionize the surrounding gas, causing the nebula to glow brightly in visible light, particularly in hues of red and pink due to ionized hydrogen. The Orion Nebula is a treasure trove for astronomers because it provides a close-up view of the early stages of star formation, allowing scientists to study how stars and planetary systems come into being. Next is the Crab Nebula, a remnant of one of the most famous supernova explosions in human history. Located about 6,500 light-years away in the constellation Taurus, the Crab Nebula, M1, is the aftermath of a supernova that was observed by Chinese and Middle Eastern astronomers in 1054. They reported seeing a guest star that was so bright it could be seen in broad daylight for weeks before gradually fading from view. This guest star was actually the light from a dying star that had exploded, scattering its outer layers into space. What remains today is the Crab Nebula, a glowing cloud of gas and dust that is still expanding outward at incredible speeds. At its center lies a pulsar, the rapidly spinning core of the original star, which emits powerful beams of radiation. The Crab Nebula is a prime example of how supernova remnants enrich the interstellar medium with heavy elements like oxygen, carbon, and iron. Elements that will one day become part of new stars, planets, and perhaps even life. It's also an important object for studying the life cycle of massive stars, demonstrating the violent yet creative processes that shape the cosmos. Finally, we come to the Barking or Eagle Nebula, home to the iconic Siri Pillars of Creation. This nebula, located about 7,000 light-years away in the constellation Serpens, is a region of active star formation, much like the Orion Nebula. The Eagle Nebula is famous for the towering structures within it, known as the Pillars of Creation, which were captured in one of the most famous images ever taken by the Hubble Space Telescope. These pillars are enormous columns of gas and dust, each several light-years tall, where new stars are being born. The Pillars of Creation represent the densest regions of the nebula, where gravity is causing the gas and dust to collapse and form new stars. Surrounding these pillars are the powerful winds and radiation from nearby young stars, which are slowly eroding the structures and dispersing the gas. The Eagle Nebula, like the Orion Nebula, offers a window into the early stages of star formation, but its dramatic appearance has also made it one of the most visually stunning objects in the sky. The interplay between creation and destruction in this nebula symbolizes the constant cycle of renewal that takes place throughout the universe. Each of these nebulas, Orion, Crab, and Eagle, offers a unique perspective on the life cycle of stars and the processes that shape the universe. The Orion Nebula, the stellar nursery where stars and planetary systems are in the earliest stages of formation. The Crab Nebula is a testament to the violent death of a star and the creation of new elements that will go on to form future stars and planets. The Eagle Nebula, with its majestic pillars of creation, provides a striking view of the process of star birth, with its towering clouds of gas and dust giving birth to new stars, even as they are being eroded by the intense radiation from older stars. Together, these nebulas demonstrate the beauty, complexity, and interconnectedness of the cosmos, showing us how stars are born, live, and die in a continuous cycle that has been unfolding for billions of years. Observing nebulas is a complex and fascinating endeavor that requires a range of advanced technologies to reveal their beauty and intricacies. These vast clouds of gas and dust are so large and distant that, to fully appreciate and understand them, astronomers use different types of telescopes, each capturing a different portion of the electromagnetic spectrum. From optical telescopes that capture visible light to radio telescopes that reveal hidden structures, and space telescopes that peer through wavelengths blocked by Earth's atmosphere, the tools we use to observe nebulas are as diverse as the objects themselves. First, we have optical telescopes, which are perhaps the most familiar instruments used to observe nebulas. These telescopes capture visible light, the portion of the electromagnetic spectrum that can be seen by the human eye. When you look at the beautiful images of nebulas like the Orion Nebula or the Eagle Nebula, you're often seeing data captured by optical telescopes. These telescopes use large mirrors or lenses to collect light and focus it into a sharp image. Optical telescopes allow us to see the stunning colors of nebulas, often reds, pinks, and blues, caused by different elements in the nebula emitting or reflecting light at specific wavelengths. For example, hydrogen gas glows red when it is ionized by nearby hot stars, while dust reflects blue light more efficiently, giving reflection nebulas their characteristic hue. Optical telescopes are ground-based, such as the large observatories located in remote areas like Chile or Hawaii, but they are also used in space-based missions, like the Hubble Space Telescope, which avoids the distorting effects of Earth's atmosphere. However, nebulas are not just visible in the light our eyes can detect. Much of their structure and activity occurs in wavelengths beyond the visible spectrum, such as radio waves, infrared, and ultraviolet. This is where radio telescopes come into play. Radio telescopes don't capture light in the traditional sense, but instead detect radio waves, which are a form of electromagnetic radiation with much longer wavelengths than visible light. These waves allow astronomers to peer into parts of a nebula that are otherwise hidden. For instance, regions of dense gas and dust where new stars are forming can block visible light but are often transparent to radio waves. By using radio telescopes, scientists can observe the cold, dense regions of nebulas and map out the distribution of molecular gases like hydrogen and carbon monoxide. This gives us a clearer picture of the nebula's structure and composition, as well as the processes that lead to star formation. A famous example of a radio telescope used in nebula observation is the Atacama Large Millimeter Submillimeter Array in Chile, which has provided groundbreaking insights into star-forming regions. Another critical tool in observing nebulas is the Hawk Space Telescope, which can observe in wavelengths that are blocked or absorbed by Earth's atmosphere. Earth's atmosphere protects us from harmful radiation, but it also filters out many types of light, such as ultraviolet and infrared, making it difficult to study certain features of nebulas from the ground. Space telescopes like the Hubble Space Telescope and the James Webb Space Telescope are positioned above Earth's atmosphere, allowing them to capture images and data in these otherwise inaccessible wavelengths. The Hubble Space Telescope, for instance, has provided some of the most detailed images of nebulas ever captured, including the pillars of creation in the Eagle Nebula and the gas clouds of the Orion Nebula. Hubble's ability to observe ultraviolet light allows it to study the hot, young stars within nebulas and how their radiation shapes the surrounding gas. Meanwhile, the James Webb Space Telescope focuses on the infrared portion of the spectrum, revealing the cooler, dustier regions of nebulas where stars and planets are forming. Infrared light is particularly useful for looking through the dense dust clouds that often obscure optical views, giving us a glimpse into regions of space that were previously hidden. Each type of telescope provides a different perspective on nebulas, revealing different layers and processes within these cosmic clouds. Optical telescopes show us the vibrant, glowing gases and dust, giving us a sense of the nebula's overall structure and composition. Radio telescopes allow us to peer into the dark, cold regions where new stars are forming, helping us understand the conditions necessary for star birth. Space telescopes, free from the limitations of Earth's atmosphere, capture everything from the searing ultraviolet light of young stars to the cool infrared emissions of nascent star systems. Together, these technologies create a comprehensive picture of nebulas, revealing their dynamic and evolving nature. In conclusion, observing nebulas is a multifaceted process that involves a combination of optical, radio, and space-based telescopes. Each of these tools provides invaluable information, helping us uncover the hidden secrets of these stellar nurseries. The ability to study nebulas in different wavelengths allows astronomers to map out their structures, understand the forces shaping them, and witness the birth of stars and planetary systems. Through this intricate dance of light, matter, and technology, we can appreciate the full complexity and beauty of nebulas, gaining insights into the processes that drive the evolution of the universe. Nebulas play a profoundly important role in the universe, acting as the engines of cosmic recycling and the cradles of new stars and planetary systems. Far from being static, these vast clouds of gas and dust are essential to the ongoing processes that shape galaxies, form stars, and create the building blocks of planets and life. Without nebulas, the universe would lack the dynamic processes needed to sustain the cycle of stellar birth and death that has allowed our own solar system, and indeed life itself, to come into existence. Let's delve into why nebulas are so crucial to the fabric of the cosmos. One of the most vital functions of nebulas is their role in cosmic recycling. When stars die, especially those that end their lives in supernova explosions, they release vast amounts of gas, dust, and heavy elements into space. These elements include everything from simple hydrogen and helium to more complex atoms like carbon, oxygen, nitrogen, and even metals like iron. These heavier elements are crucial because they're the building blocks of planets, moons, and ultimately, life. After a supernova disperses the outer layers of a dying star into space, the remnants form nebulas, where this material is redistributed and mixed with other interstellar gases. This process of cosmic recycling ensures that elements produced in the cores of stars are spread throughout galaxies, where they can be incorporated into new stars, planetary systems, and perhaps even life forms. In essence, nebulas act as cosmic recycling centers, taking the ashes of dead stars and transforming them into the raw materials for new ones, contributing to the ongoing renewal of the universe. Nebulas also play. Within nebulas, gravity gradually pulls together gas and dust to form dense regions that will eventually collapse to create new stars. Around these young stars, the remaining material can coalesce into a spinning disk of gas and dust, known as a protoplanetary disk. Over millions of years, this disk evolves, and the dust particles within it begin to clump together to form planetesimals, the building blocks of planets. Eventually, these planetesimals can form full-fledged planets, moons, asteroids, and comets, creating a new planetary system. This is the process that gave birth to our own solar system around 4.6 billion years ago. In fact, the sun, the planets, and all the life on Earth owe their existence to a nebula that once swirled with gas and dust before collapsing to form the sun and its surrounding planets. The formation of planetary systems is an intricate process that can only occur in the dense environments provided by nebulas, making them fundamental to the creation of not only stars, but also the planetary systems that orbit them. Nebulas are also essential for the chemical evolution of the universe. In the earliest stages of the universe after the Big Bang, the universe was primarily made up of hydrogen and helium, with only trace amounts of other elements. Over billions of years, stars have fused these lighter elements into heavier ones through the process of nuclear fusion. However, those heavier elements, such as carbon, nitrogen, oxygen, and iron, don't just stay locked inside stars. When stars die, particularly in supernova explosions, they expel these heavier elements into space where they mix with the interstellar medium. Nebulas are the regions where these elements are redistributed and incorporated into new stars and planets. This process has gradually enriched the universe with heavier elements, allowing subsequent generations of stars and planetary systems to form with more complex chemistry. This chemical evolution is crucial because it's the reason why rocky planets like Earth, which are rich in elements like carbon, silicon, and iron, can form. Furthermore, these elements are vital for the development of life as we know it. In other words, nebulas don't just contribute to the formation of stars and planets, they help evolve the very chemistry of the universe, making the formation of planets and the emergence of life possible. Nebulas serve as cosmic laboratories for the creation of complex molecules, including organic compounds that could be precursors to life. In certain regions of nebulas, especially those shielded from harsh radiation, conditions are favorable for the formation of organic molecules. These include complex carbon-based molecules such as polycyclic aromatic hydrocarbons, PAHs, which are thought to be some of the basic building blocks of life. The presence of these molecules in nebulas suggests that the raw materials for life are widespread throughout the universe, possibly increasing the likelihood that life could exist elsewhere. The study of nebulas, therefore, not only helps us understand how stars and planets form, but also provides clues about the origins of life and the potential for life beyond Earth. The Kjartani Aenormatrices. Importance of nebulas. In the universe cannot be overstated. They are essential to the cosmic cycle of birth, death, and rebirth, recycling the remnants of dead stars and providing the material for new stars and planetary systems. Their role in the Vaikar redistribution of heavy elements throughout space ensures that subsequent generations of stars and planets are enriched with the elements necessary for complex chemistry and the formation of life. Moreover, nebulas contribute directly to the formation of new solar systems, acting as stellar nurseries where stars and planets are born. Finally, they play a critical role in the chemical evolution of the universe, gradually enriching the interstellar medium with heavier elements that allow for the formation of rocky planets and potentially even the emergence of life. Without nebulas, the universe would be a much less dynamic and diverse place, lacking the elements and processes necessary for the complex structures and life forms that exist today. As we reach the end of our journey through the wondrous world of nebulas, it becomes clear that these cosmic clouds are much more than just beautiful objects in the night sky. Nebulas stand as silent witnesses to both the past and the future of the universe, embodying the continuous cycle of stellar birth, death, and rebirth. They are remnants of stars that have come to the end of their life cycles, and at the same time, they are the cradles of new stars and planetary systems. These vast clouds of gas and dust are like cosmic tapestries, woven from the remnants of dead stars and stretching across time, bearing testimony to the incredible processes that shape galaxies and, by extension, life itself. In observing nebulas, we are peering into the history of the universe while also glimpsing its future. What nebulas reveal to us, cycle of life and death in the universe, is nothing short of profound. They show us that destruction is not the end, but rather a catalyst for creation. When a star dies, it leaves behind the raw material that will form the next generation of stars and planets. Nebulas illustrate the interconnectivity of all things in the cosmos, as the elements forged in the hearts of dying stars are dispersed throughout space, only to be incorporated into new celestial bodies. These very same elements, carbon, oxygen, nitrogen, are the building blocks of life, including our own. The study of nebulas, then, offers a deeper understanding of how everything in the universe is part of a grand cyclical process where death leads to new life in a never-ending dance of creation and destruction. But despite all that we have learned about nebulas, there remains a vast amount of beauty and mystery yet to be uncovered. As our technology advances, allowing us to peer deeper into the cosmos, we are bound to discover even more about these enigmatic structures. There are countless nebulas scattered across the universe, many of which remain unseen or only partially understood. Some might contain the seeds of future stars, others may hold clues about the earliest stages of the universe, and still, others may harbor the ingredients necessary for life. The beauty of nebulas lies not only in their vibrant colors and majestic forms, but also in the mysteries they hold within. Each nebula we observe is a glimpse into the unknown, a cosmic puzzle waiting to be solved. If this journey through the nebulas of the universe has ignited your cosmic curiosity, then you're on the right path. There's so much more to explore, so why stop here? Be sure to leave a like and subscribe to Exploring the Universe for more exciting adventures through the wonders of deep space. Together, we'll continue uncovering the secrets of the cosmos, diving deeper into the stellar nurseries and other awe-inspiring phenomena that make our universe so endlessly fascinating. Join us as we travel through the stars, uncovering the mysteries that lie beyond, and embark on new journeys through the fabric of space and time.